In 1996, a skull surfaced from the Columbia River that scientists declared looked nothing like Native Americans. For nearly 20 years, that claim held up in federal court was weaponized by white supremacists and kept 5 tribes from burying their ancestor. Then a fragment of bone entered a DNA lab, and the secret locked inside this 9,000-year-old skeleton dismantled the very science that had kept him from going home. A hot July evening on the banks of the Columbia River, 2 college students, waist deep in the water, stumble over what they think is a rock. It is a human skull, heavy and ancient, resting in the mud just below the surface. The discovery triggers a chain reaction. Police are called, then the Benton County coroner, who wastes no time summoning James Chatters, a forensic anthropologist known for his sharp eye and steady nerves. Chatters arrives with his field kit, expecting a recent crime scene. But the skull tells a different story. Its features are unfamiliar, the bone dense and stained by centuries underground. As he combs the shoreline, Chatters uncovers more bones, ribs, vertebrae, the long arc of a femur. Piece by piece, a nearly complete skeleton emerges, astonishingly well preserved for its age. Only about 50 such ancient skeletons have ever been found worldwide, and most are fragmentary. This one is intact, a rare find in North American archaeology. The examination reveals something even more startling, a stone spear point still embedded in the right hip. The wound had healed, evidence of survival after a violent encounter thousands of years ago. Chatters documents every detail in his notebook: bone measurements, sediment layers, the exact position of the projectile. Forensic notes record an adult male, about 5'7", with robust bones and signs of old injuries. A tiny sample of bone is sent to the University of Washington AMS lab for radiocarbon dating. The result comes back, 8,410 years before present, plus or minus 60 years. Calibrated, the age falls between 8,400 and 9,200 years old. This is not a pioneer, not a settler, not a recent ancestor. The skeleton predates every known civilization in the region. Its existence challenges everything archaeologists thought they knew about the earliest people of the Americas. Douglas Owsley, a forensic anthropologist from the Smithsonian, stepped into the spotlight with calipers and a database of skull measurements from around the world. He spent months recording the angles, lengths, and arcs of the Kennewick Man's cranium, over 400 data points in all. The numbers, when run through statistical models, pointed not to modern Native Americans but to the Ainu of Japan and certain Polynesian groups. Owsley's findings landed in the press, and the word Caucasoid began to surface in headlines. Newspapers speculated about a white ancestor in ancient America, and the story quickly spun out of the scientific journals and into the daily news cycle. In 1998, the public got a face to match the controversy. Using a silicone cast of the skull, Owsley's team produced a 3-dimensional facial reconstruction. The model, with its broad cheekbones and pronounced brow, bore little resemblance to the local tribal members who watched the process with growing anger. Smithsonian press releases and magazine covers ran the image alongside phrases such as "The Mystery of Kennewick Man" and "Was he the first American?" The headlines caught the attention of groups far outside the scientific mainstream. The Asatru Folk Assembly, a white supremacist neo-pagan organization, seized on the facial reconstruction, circulating it online as proof of a supposed ancient European presence in North America. Their statements twisted the findings, claiming the Ancient One was a pre-American Viking and using the controversy to bolster their own claims of racial heritage. This appropriation fanned the flames of public debate and forced scientists and tribal leaders alike to confront the ways in which scientific interpretation could be weaponized for political ends. As the reconstructed face appeared in museums and news stories, the remains became more than a scientific specimen. They became a symbol, fought over in headlines and courtrooms, their meaning reshaped by each new interpretation. For the tribes, seeing their ancestors' features displayed to the world was a fresh wound. For the public, the Ancient One became a canvas onto which America projected its oldest questions about who belongs and who decides. 5 tribal nations, the Umatilla, Yakima, Nez Perce, Wanapum, and Colville filed a formal claim under the Native American Graves Protection and Repatriation Act, insisting that the Ancient One was a direct ancestor and must be returned for reburial. Their petition landed on the desk of the U.S. Army Corps of Engineers, the federal agency holding the remains. The Corps, citing the skull's unusual features and the immense age revealed by radiocarbon dating, issued a determination of non-affiliation. According to their internal memos, the remains could not be confidently linked to any present-day tribe. This decision set the stage for a high-stakes legal confrontation. A coalition of scientists, led by Douglas Owsley and backed by the National Science Foundation, filed suit in federal court. Their argument was blunt: the remains were too ancient and the skull's measurements too distinct to fall under the act. They demanded an injunction to block repatriation and to guarantee access for ongoing research. Court transcripts from the Eastern District of Washington show lawyers for the tribes arguing that oral histories and the location of the find provided cultural continuity, while the scientists presented cranial metrics and statistical models as evidence of a separate, older population. The case climbed to the Ninth Circuit Court of Appeals in 2004. The judges sided with the scientists, ruling that the Native American Graves Protection and Repatriation Act required a demonstrable cultural affiliation, not just geographic or spiritual ties. The court's written opinion leaned heavily on the skull's morphology, accepting it as legal evidence of non-affiliation. For the tribes, the decision was devastating. The Ancient One would remain in museum custody, locked in the Burke Museum for nearly 2 decades, measured and sampled, but denied to his descendants. The legal standoff left the remains in limbo, with no resolution in sight and no clear path to healing. Permission to sample Kennewick Man's remains arrived in 2015. The request was precise: a 200 milligram fragment of hand bone, just enough to attempt something that had failed in every previous effort, extracting ancient DNA from a skeleton this old and this degraded. In the lab at the University of Copenhagen, Eska Villerslev and Morten Rasmussen faced a daunting challenge. The bone's own DNA made up less than 1.5% of what they could recover. The rest was a tangle of microbial sequences, the legacy of millennia in wet riverbank soil. Standard methods would have produced little more than noise. The team turned to single-strand library preparation, a technique that can capture even the shortest, most damaged fragments of ancient DNA. They paired this with in-solution hybridization capture, using modern human DNA as bait to fish out the rare ancient molecules from the sample. Every step was optimized for loss. The tubes were chilled, the reagents filtered, the lab coats changed at every stage to avoid contamination. After weeks of work, they had enough data for a rough draft of the genome, about one-fold coverage, meaning each position in the genome was read, on average, just once. With so little endogenous DNA, every base pair counted. The results were triple-checked, then sent through comparative analysis against hundreds of modern and ancient genomes. The findings were submitted to Nature, the world's most prestigious scientific journal, where the paper underwent months of peer review. Publication in 2015 transformed a decade of speculation into hard data, setting the stage for a definitive answer about Kennewick Man's origins. The genome data arrived in the form of raw sequences, thousands of fragments, each one a clue to the Ancient One's true identity. Population geneticists turned to principal component analysis, plotting Kennewick Man's DNA against hundreds of modern and ancient genomes. The result was clear. The closest genetic relatives were not Europeans, Ainu, or Polynesians, but members of the Confederated Tribes of the Colville Reservation and other Native American groups from the Pacific Northwest. F4 statistics, a tool for measuring shared ancestry, confirmed the verdict. The numbers showed no statistical affinity with European populations, no special link to the Ainu, and no evidence for a separate Paleo-American lineage. The so-called Caucasoid skull had misled a generation of scientists, but the DNA left no room for doubt. The findings landed with the force of a legal ruling. David Reich, a leading geneticist at Harvard, stated publicly, "The genome of the Ancient One falls squarely inside the variation observed in present-day Native Americans. It provides a decisive refutation of the long-standing claim that the skull's shape implied a non-native ancestry. The entire framework of skull-based ancestry inference, once the gold standard in physical anthropology, collapsed under the weight of genomic evidence. For the tribes, the data affirmed what their oral histories had always maintained. For the scientific community, it was a reckoning. The past could not be reconstructed by calipers and statistics alone. DNA, not bone shape, had the final word on the Ancient One's origins. Science once claimed Kennewick Man rewrote who belonged here. But DNA, published in Nature at just 1.4% endogenous, proved ancestral ties run deeper than bone shapes or courtroom arguments. Today, every ancient discovery tests whose story gets told. The real question is, who decides what becomes sacred and what becomes evidence?